All right, hey guys. I am out again today. So instead of doing the next lesson, we are just going to do our review, which we were going to go do Tuesday. I'm going to do it today instead. So I'm going to go over what is on the test for Module 11 and 12. You can use one index card on the test. So if you have an index card, you can go ahead and get one out and write down anything you feel like you need to write down. Otherwise, just take notes in your notebook and you can transfer it to an index card later. Your test will be on Wednesday next week, okay? As of right now, pending when I am back, but the plan is for Wednesday next week, okay? And again, everything that I do today is on the test. All right, so first thing that you are going to see, we are going to be talking about exponential growth and decay. So we have some functions. And I want to know, could you write a function for both of these functions? So go ahead, pause the video, and you try to write the function for it. All right, so the first function should be something like this. The starting value is 3, so I start with 3 times the growth. Well, I can kind of see this. It went from 3 to 12, so if I do 12 divided by 3, that's 4. So my growth is 4, so times 4 to the x. Or that's my multiplier, so my multiplier is 4. All right, let's take a look at the second table. And I notice, again, that it starts out at 5. So my initial value is 5, and it looks like it's getting 6 times bigger each time. You could get that by doing 30 divided by 5 or 180 divided by 30. So it would be times 6 to the x power here. Now, if I had you fill in the table for the third, I would just plug in a 3 here, or I could just times that by 6, and I could get that last value, which would be 1,080 if I type that in correct. All right, so that should be a couple easy points on the test. All right, the next thing that you will see on your test is basically identifying for me if these functions are growth or decay. So I have 2 lines on the first graph, I have a table, and then 2 functions. Can you pause the video and tell me what you think for each of them? Are they growth or decay? And how do you know? You will have to explain it on the test. So you have to be able to give me some kind of reason. All right, first one, this pink one here, that is decay. Okay, as you look kind of from left to right, it is going down, okay? So that could be a reason. The green one, this is growth. Okay, as you go from left to right, it continues to increase. All right, so that one's increasing. All right, let's look at the 2 equations. So this one and this one. All right, my initial value is 40. It looks like my growth factor, or I'm multiplying it by 6 each time, so it's getting 6 times bigger, so this would be growth. This one here, it looks like it is decaying because it goes down or multiplies by 0.75, which is less than 1. So it's going down each time. It's decaying. It's losing 25% of its value each time. It's keeping 75%. So a lot of reasons you could give me, but that is decay. Again, you'll have to be able to give me a good reason. All right, my table. Obviously, you guys should be able to tell it's going down. So this is decay as well. You could find out what it is going down by doing 64.5 divided by 86. That would give you that factor. All right, so here is our next one, and you are going to pause and do this one, and then when you're ready, push play. So please actually try it, and then you can watch me do it too, or then you can correct it. So it says George invested $45,000, so maybe he got like a bonus, or I don't know, somebody gave him $45,000, or he won that, and he's going to earn 3% annually. That means every year. Okay, so I want to know how much money is he going to have in his account after 1 year, 2 years, 6 years, 10 years. Could you write me the function for this appreciation model? And then could you find out how much money he has after 16 years, and then how much interest he made during those 16 years? All right, please pause the video and try that. All right, so he started with $45,000. All right, after 1 year, okay, if we look at this, after 1 year, he's going to earn that he's got to keep that $45,000. And then if you're using your formula, you would say, well, he keeps 100%, that's the 1, plus that 3%, and 3% as a decimal is 0.03, so plus 0.03, and I'm going to take that to the first power. Okay, so obviously if you were writing the function, it would look something like this. F of x equals 45,000, okay, times 1 plus 0.03 to the x power. Now, or to the t power, or any power, whatever. Well, I said years, so x. Now, some of you might write it as 45,000 and then times 1.03 to the x. That's fine as well, as long as you can explain where you got that from. So if you work that out after 1 year, okay, I have to do that quick. Oops, got to turn my calculator on, sorry. Well, that's just to the first, times 45,000. I think it's $46,350. Okay, I'm going to do the next ones and just put the answers in the video here. All right, go ahead and check out the table. I did it for 2 years, 6 years, and 10 years. Now, again, hopefully I didn't make a mistake. I did not double check this just for time's sake. So if I made a mistake, I've maybe just typed something in wrong or copied it down wrong, but it should be pretty close to that. Okay, so how much money after 16 years? So if you were going to do that, you would do 45,000 times 1.03 to the 16th year. Now, when you type that in, you have to do the 16th power first. All right, so when you type that in, again, I typed it in quickly, so hopefully it's right. I got 72211 and 79 cents. Make sure you round because it's money. So that is what I got after 16 years. So if I want to know just how much interest he made, because he didn't invest any more money, he only just put that $45,000 in, I could take the new amount that he had, and I'm going to subtract that 45,000 because that's what he started with. And that will give me how much interest he made. So if I subtract that, it looks like I end up with 27211.79. Again, if I did that correct, so he made $27,000 in interest, which is crazy. Okay, so that is why people definitely invest money, so you can make more money. All right, so hopefully if you have any questions on that, please let me know. All right, next thing that you will see on the test are the laws of exponents. So I'll quickly just do these very, very quickly. Again, you write down what you need to on your index card, or if you think you need to write down any of the rules, we took good notes on these. So they are there. So if I was doing this first one, when I am multiplying exponents with the same base, the shortcut rule is you can add those. If you weren't sure, just write it out the long way. So I expand it. Okay, I get x to the 7th. And then over here, the y's, I also get times y to the 7th. It's as far as I can go. Okay, second one, any number to the 0 power is always 1. Again, if you want to pause these, you might want to try this first, and then you can correct them. All right, this next one, this sometimes gets a lot of people. You have to do everything inside here to the 3rd. If you weren't sure, just write it out the long way. So 10x squared times 10x squared, 3 times, right? 10x squared. Well, when I multiply, it doesn't matter the order. So 10 times 10 times 10, that's 10 to the 3rd. And then x squared times x squared times x squared, that's times x to the 6th. So I get 10 to the 3rd times x to the 6th. You could work out 10 to the 3rd. So 10 times 10 times 10, which is obviously 1,000. So I would also take 1,000 x to the 6th. All right, let's go to the negative exponents here. Anytime you have a negative exponent, remember, rewrite it as 1 over x to the 3rd. Same thing here. This would be the same as 1 over 5 to the positive 3rd. Again, you could work that out. 5 times 5 times 5 is 125. All right, so when I have this one, x to the 15th over x to the 5th, the shortcut rule is you can subtract the exponents. So the top minus the bottom, I am left with x to the 10th. And finally, this last one way up here on the top, you take everything inside there to the 4th power. So shortcut rule is you can multiply. So I'd have x to the 12th over, I have to do that to the 4th power too, 2 to the 4th, or x to the 12th over, if you do 2 to the 4th, 2 times 2 times 2, 16, I think. So there is my final answer. All right, the last thing that you're going to see on your test is you're going to have to be able to compare some functions, okay? So they're going to give you a couple functions, some different situations, and you might just have to compare them. So let's just pretend that this is like the zombie thing that we were doing, and I give you 2 cases, and I want to know which case is growing faster, okay? And then which case were there more zombies initially? Okay, so which one had more zombies initially? Okay, so to find that, we can obviously look at case 1, or if you want to pause the video, try it quick. But case 1 started with 500, and it looks like it is tripling. So I had 500 initial zombies and tripling each time. Case 2, now I have to do a little work here. I got to go back to get this. Well, let's just kind of see what it's growing exponentially by. So I'm going to do 10,000 divided by 2,000. Which ends up being 5. So it looks like it's multiplying by 5. So if I want to go backwards, I'll divide by 5. So 2,000 divided by 5 gives me 400. Okay, so if I was going to write this rule, I would say f of x equals, initial amount is 400, and it was multiplying by 5, so times 5 to the x. I could put that in parentheses. All right, so it looks like this function now, there were initially 400 zombies, but it is multiplying by 5 every day, if this was days. So which one's growing faster? I would say case 2, okay, because it is multiplying by 5 each day. Which one had more zombies initially? Looks like case 1 had 500 zombies to start with. All right, the last thing is I might give you the same kind of thing, maybe with these zombies again, and it's growing, so kind of ignore this part over here because it won't start. But I would ask you, I have 2 graphs, and I'd probably give you some numbers on these graphs, but I want to know, could you tell which one had initially more zombies? Okay, and then which one is growing at a faster rate, and how do you know? And then which population might have more zombies in the long term? Okay, so there'd kind of be 3 questions. So obviously the initial, you can kind of tell here, obviously this number, maybe this is 40, this is 60. This number is obviously bigger. So the red one had initially more zombies. Okay, now which one's growing faster? Well, you can see the green one overtakes it. So the green is obviously growing a little bit faster. If I gave you the equations, you would be able to tell by looking at the growth factor. So if I told you one was like 40 times 3 to the x, and the other was 60 times 1.7 to the x, you would obviously be able to tell me that that one is growing faster. In the long term, it's going to be obviously the green one still, because it overtook it and it's still increasing. So that one will grow the most in the long term. And then finally, you can tell where they had like the exact same amount would be this point right here where they intersect. All right, so hopefully you'd be able to answer all of those questions and explain your choice. All right, so that is what kind of questions you are going to see on your test. Hopefully you feel prepared for it. So your task now is to make an index card with anything you want on it. Okay, a small size index card, so normal, front and back. You cannot type on it, it just has to be handwritten. You can put anything you want on that index card. From this chapter, you might want to go back and look at your notes. You might want to look at our exponent laws. And then you're going to go to Schoology and you are going to complete the task that I have listed in Schoology. If you finish those tasks, then I want you to go back and check, do you have any late work? If you finish all of that, then please work on Alex or Reed, but do not be distracting to everybody else. So we're staying in our seats, and you should be working on these things the rest of the class period. If you have any questions, you can go into the class kick or the Zoom to ask me, okay? So I will be there to answer questions.